Good morning, everyone. My name is Ahsan Raja. It's an honor to present at this forum. Our study is on a systemic review and meta-analyses on HSI, hyperspectral imaging for the detection of skin cancer. So skin cancer is a leading cause of cancer-associated deaths globally. Early detection is challenging. Hyperspectral imaging, which I'll be referring to as HSI from now, is a novel visual diagnostic modality. It's been recently adapted for skin cancer screening in dermatologic trials. This image is an example of how the HSI system can be set up. So here in this image, we can see an example of an image. The image is basically broken down into pixels, and each pixel has an entire wavelength, which is broken down in hundreds and thousands of bands compared to the usual red, blue, and green. So we can get significantly more information from the image that we get. Here's a flow diagram of how the whole image acquisition up until how the HSI system algorithm identifies the lesion. There's processing it between cleaning up the image and then finally outputting it and validating it. So these are two examples of how the HSI system outputs. On the top left, you can see an image that was processed by the algorithm. And on the bottom left, you can see it was identified as malignant melanoma. On the top right, you can see another image which was identified as basal cell carcinoma by the algorithm. Here are some key points. AI algorithms, when combined with HSI, has potential for early detection, accurate lesion classification, as precise delineation, and possible reduction in invasive biopsies. Recent studies have been very promising with up to 95% sensitivity and 97% specificity. So we did a meta-analysis of data of 10 years from 3 databases. Our inclusion criteria was images of patients with skin lesions. Intervention was HSI. For skin cancer diagnosis, comparator was actually histopathological diagnosis, and outcomes were sensitivity as a diagnostic performance of HSI. So this is how we went about from extracting the studies from 3 databases, and we ended up with 7 studies that we made pool and made forest plots for. We made the forest plots in RStudio with and had the p-value of less than 0.05 as statistically significant. Here's the forest plot for sensitivity. The pool sensitivity was 95% with a p-value of less than 0.01. Here's the forest plot for specificity. We found the pool specificity to be 89% with a p-value of 0.006. So concluding, HSI demonstrates notable sensitivity and specificity for detecting skin cancer. When combined with AI algorithms, it has significant potential for detecting skin cancers. And thank you.